Hello everybody, my name is Murray Reid. I am a geologist. I live in Kirkintilloch and I'm a member of the Kirkintilloch Society of Antiquaries. And during the recent lockdown that we had in the spring, I took the opportunity when I'm out on my daily walk to try and get some pictures of geological exposures or things in the neighbourhood that I could easily see just from the daily walk and footpaths and things like that that were readily available. And gradually thought that I could put this together into a presentation that would tell us something about the geology of the Kirkintilloch area, how we know what it is, which is basically down to how humans have interacted with it over the centuries, and augmented the slides taken during the lockdown with ones I'd taken previously, like the one you can see on the cover slide before you, which is from January 2018, to make a complete and comprehensive record of what the geology of our local area is, including, I say, up Milton of Campsie and Lennoxton, as well as Kirkintilloch. Uh, Without further ado, I'll go on and explain what I'm going to talk about. Start with a bit of an introduction, as you always should. Then to talk about the Campsies, which of course lie to the north and dominate the view from Kirkintilloch, so we can hardly ignore them. Then going to look at some other igneous rocks, dolerite dikes, which tend to stick out a bit and are some of the rocks that one can actually see around about the landscape. We'll look at some old quarries and some of the things that can be seen in them, particularly sandstone. And then looking at evidence of underground workings from colliery spoil tips and what they tell us about the strata below the ground. That naturally leads on to looking about the old mine workings and the evidence of them in the neighbourhood. Then I'm going to look at the sort of superficial deposits that cover the ground all around here, and so it needs to, I think, to say a little bit about them before we finish. So there's two main types: glacial till, glacial deposits, known as Boulder clay, and there's a Kelvin Valley, which is a major topographic feature in central Scotland and largely infilled with sand and gravel and other materials. So that's the story, and without further ado, I'll get on to the introduction. The slide shows the view, which is from a well-known local viewpoint, which I'm sure many of you will have guessed where this is. But if you haven't, don't worry, I will come to it in due course during the presentation. But as you can see, there's not a lot of rock immediately visible from this viewpoint, except in the Campsies in the distance. So let's go on and have a look, think about what we're actually trying to do here. Look at geological maps, they're lovely things, that they're beautiful, bright colours all over the place. But as you actually walk around, as you can see from the previous slide, there's hardly any rock exposed. So how do we know what's actually down there? What do they put on these wonderful maps? And of course, it's mainly from human activities, which is where the link to the antiquaries and local history comes in. There's old pits and quarries for all sorts of materials. Sand, gravel, sandstone, limestone and dolerite we've used for construction. There's records of mine shafts and old mine workings for coal and other minerals like ironstone that fueled the Industrial Revolution. In more recent years, we've had a lot of ground investigations for development of individual sites, big buildings, developments, transport routes like roads and railways as well. And of the actual cuttings and other excavations for the roads and railways and so forth, some of which are go back to Victorian times, others of which are much more recent. So how can we use all this evidence and what to tell us about what we can see that lies beneath? I'm going to start, as I previously said, with the Campsies, which again here in a beautiful winter's day with the snow on the hills, of blue sky behind, dominate the horizon. And just to show that they aren't only visible in winter, we've got a slide taken in May of this year from Peel Park, that the Campsies lie to the north there. This range of hills, which goes up to almost 2,000 feet, are a pile of basalt lavas of Carboniferous age. That's about 340, 350 million years ago, something like that. So they're hard rock, so they formed this highland, this upland, and they're bounded to the south by a very steep scarp, which is because there's a major fault runs along there, the Campsie fault, down throws to the south, and the area from the Campsies to here that you can see in the photograph, the undulating ground, is underlain by sedimentary rocks, sandstones, mudstones, and odd limestones and things, again of Carboniferous age, but younger than the lavas, say about 300 to 340 million years old. So there's a distant view of the Campsies. Let's get a little bit closer and have a better look at them. And thankfully, due to our great network of paths, we can get quite a lot closer to them and get a better view of the hills. If we go up the Strathkelvin Railway Path, which is a feature I will be returning to many times in the course of this presentation, wonderful path. And go up through Milton of Campsie and a little bit to the west up there, you get a wonderful view of the Campsies immediately to the north. This was taken actually in February of this year in one of our brief wintry interludes, and you can actually see the individual lava flows there picked out by these lines of the snow lying on the top of the individual lava flows. The Campsies have a sort of stepped or terraced appearances, which is down to just the tops of the individual lava flows having weathered after the lava was erupted before the next lava came over the top, so that it preserves this sort of stepped or terraced appearance. And that's what we can see in there. These individual lava flows can be traced for large distances along through the Campsies. And I say there's no problem of lack of exposure or not knowing what the things are there. Geologists can go up and examine the strata quite directly. So that's the Campsies. Move into the lower ground around about Kirkintilloch, we'll find there's not nearly so much rock that's exposed, but what does pop through occasionally is again igneous rocks, but not in the form of lavas, but in the form of these dolerite dikes or ridges across the landscape. This one here is on the Bothlin Burns at the Bothlin Bank, so it's south of the railway, the Edinburgh-Glasgow Railway. The river's actually flowing to the north here from right to left. And the ridge that you can see in the middle distance running across from left to right, that is going from west to east. That is this dolerite dike, which is one of a number of bands of narrow vertical bands of igneous rock intruded into the sedimentary rocks of Carboniferous age. Compositionally, this is very similar to the basalt of the Campsies, but it's actually much younger geologically. The Campsies, the lavas of the Campsies are sort of lower Carboniferous, then you've got all the main Carboniferous sedimentary strata, sandstones, mudstones, and coals, and so forth. And then a little bit later than that, sort of younger than 300 million years, these dolerite dikes intruded up from below into the strata and forming these upstanding ridges that run across the countryside. They can be up to 30 meters wide, they can be as little as 1 meter wide. And so they're exposed in quite a number of things, in natural outcrops and in railway cuttings and things of this sort. And also, if you follow this one here, east towards Mollinsburn, you can see a big outcrop of it on the M80 there, and in the ridge behind that, leading up beyond Mollinsburn. So these vertical dikes can be traced for long distances, some of the bigger ones. They run in an east-west direction on there. Let's get a little bit closer and see what this looks like a little bit closer up. Here, if we go around to Bothlin Bank and over the weir, and we can walk around the edge of the dike and along the edge of it and have a look at the exposure that we could see from the distance in the previous photograph. And what we're doing here is we're looking along the outer edge of the dike, parallel to its length. And what we've got really is effectively the chilled margin, where the liquid magma has been intruded and has come up against the surrounding country rock. So it's solidified very quickly and gives you this chilled margin with this sort of irregular fractured appearance all along there, all very closely jointed. However, we can, in other exposures, see what the inside of the dike looks like, and that's where we're going to go next. If we go up the railway path all the way to Milton of Campsie, through the old station, and just beyond that, heading west,
you're going through a cutting there, which is actually through another dolerite dike. It's not the same as the one at Boulder Bank we were looking at previously, but it's the same suite. It's the same, these ones running east-west. This is what the inside of the dolerite dike looks like. You can see this blocky, angular fabric that it has due to the cooling and contraction of the magma as it's cooled slowly in the country rock rather than being extruded out on the surface like the lavas of the Campsies. So this, if you get up close to it and knock a bit off, you can actually see the individual grains all interlocking, about sand-sized in there. But there's no sort of obvious bedding or layering in there. Instead, it has this sort of angular jointing appearance, which comes from the thing cooling from a magma and solidifying in the cutting. So this is well exposed here. And again, was very well exposed at this time in April, before all the vegetation got up and got growing, and it's much harder to see all these exposures in the summer. But the spring is perfect because the light's good and the vegetation hasn't got up yet, and gives us the opportunity to get out and actually look at some of these exposures. And if we come out from the Milton of Campsie, the old railway station on the path, and walk down Mudstone Road to the bridge over the Glacial water and look over at times of low flow, you can see the dike down in the bed of the stream here. And you can see again the same pattern of jointing where the thing is solidified and has solidified and contracted to give you this fractured sort of appearance. Again, you can see the vegetation developing very rapidly, so this has to be viewed at times A of low flow and B during the winter or early spring when the vegetation is all dead and you can actually see it in there. But that's that's the dolerite dike down there. So that's the dolerite dikes, the igneous rocks. What about all the sedimentary rocks that form the bulk of the succession of the low ground on which Kirkintilloch and Lennoxton sit? Well, one of the ways that we can see what this is, most of it's hidden by superficial deposits. Now and again, man has dug into it to extract something of value, and occasionally some of these exposures are still available, as in this case here. This is a quarry down below the old Isle Cemetery and above the Bothlin Burn, and just opposite from the old Lee Hospital site. And in fact, the sandstone from this quarry is thought to have been used in the construction of the hospital. But nowadays there's very little left to indicate that the quarry was actually there, and this is only visible at the winter and in the spring because all the trees are bare and you can see it, but it's just beside one of the paths as you down out of the old Isle cemetery. This is as close as I could get. Even in April, the quarry is infilled with very soft material, and it was even at that time it was very, very soggy. I could get a few meters further in from the path, but not too far. So we have to make do with this rather distant. You can see from it in here, bedding in the sandstone. This is all kind of horizontally bedded, dipping down towards the left, and also actually into the face of the quarry there. Well-bedded sandstone. These are river sediments laid down by big rivers coming out into the delta, and the mudstones and the siltstones are sort of the muds and things laid down in the deltas and swamp areas around there. Not many of these old quarries. A lot of these old quarries are out, but very few of them are exposed. They've mostly all been infilled and smoothed over and built over. This is a nice example of one that you can actually go and have a look from a safe distance at the strata. However, you can actually have a better look at the strata by just wandering up into the old Woodley Hospital site, and a few of the old buildings are left, and of course they were constructed with sandstone, and there it is in all its glory. Typical Carboniferous sandstone, off-white, fine-grained, nice building stone that makes excellent building stone in there. Much of Glasgow was constructed using sandstones. Down the road in Bishopbriggs, there was a thick stratum of sandstone known as the Bishopbriggs sandstone, which was very extensively used for this purpose, tenements and public buildings and so forth. Where I come from, which is Kirkintilloch out on the south side, is another brand of Kirkintilloch sandstone, which was mined and quarried extensively around where I grew up, and those are the main sources. This little sandstone at Woodlea here is thought to be the Cowlairs sandstone, which is a one a little bit lower in the sequence than the Bishopbriggs sandstone, but it's very much the same sort of material. So we can actually see what the strata is like through the activities of man in digging it out and using it to build buildings with. And the next further evidence that we get at the surface of what's beneath the surface comes through the spoil tips of old collieries, of which there's still a few left around the neighbourhood, although many have been removed over the years. And this is one in particular that may be familiar to many people. From the other side, and there's no prizes for guessing that this was also where I took the picture that we saw at the start of the presentation of the view over Kirkintilloch into the Campsies. This is the Waterside Bing, or to give it its proper name, the spoil tip from the former Wester Gartshore colliery. And the shape of these things, you can see the ramp shape of it there, very much illustrates the method of construction. An end-tipped ramp. Basically, they ran the wagons full of the spoil from the shafts and the underground workings up the slope, tipped them, and ran them back down again. And the next wagon went up and tipped its lot. Over time, these ramps would coalesce, ones from several different shafts and various, and you end up with a huge, big, irregular sort of blob or mound shape. And there have been a lot of these around the area, but they've mostly been removed now. Those of you who were at Edward Smith's presentation on Waterside, showing photos from Waterside in March 2019 in the Barony Chambers will remember he showed a number of pictures of large spoil tips round about there. This one is left, and it's good that it is, because it reminds us of the heritage of mining and how our predecessors made their livings and the costs of that in terms of the environment that the sites round about. Of an end on one of the ramp shows you the angle of the thing. One of the reasons that the tip stands out is it's much steeper and higher than any of the natural hills round about, because basically the material is tipped and as its kind of angle of repose. So there's always little minor slips and slides going on down there during wet weather or whatever, so it's hard for the vegetation to get established. But you can see it's done. The trees have done a pretty good job around there. So let's have a look up onto the ramp and see what the material is actually like. And this is us up on top of the ramp, looking down, and the strata that the tip consists of is mostly mudstone. There's some sandstone, bits and pieces of other things, but mostly mudstone. It would have been brought out in fairly large chunks from the excavations for the shafts and the workings, but it rapidly breaks down when it's exposed to the atmosphere. You get wetting, drying cycles, freeze-thaw cycles, heating and cooling, and the mudstone is very weak, so it contracts and crumbles to this sort of gravelly-like material, which gets very soft and slippy when it's wet. So it's definitely worth saving a visit for this to a dry spell. It's much easier to get up and down on there. I've been on several occasions, and I've not been able to find any fossils in the mudstones. The mudstones in this strata is mostly terrestrial strata. It's deltaic sort of muds and things of that sort, rather than fully marine muds. So you don't get much fossils in there. But you do get excellent views from the top. Yes, you can see Arran on a clear day. Looking out to the west, the hills of Arran are visible in the distance. In this case, we're really just looking down at Waterside, back down the ramp to show you what the material looks like. The best way to get to it is actually to follow the footpath beside the Bottle Burn from Waterside up along to the stepping stones, then just keep on going for about another 100 yards or so, and you can get into the old the workings and then up onto the bottom of the ramp and up it that way. Actual exposures of mudstone are rather hard to find. Here's one here in the bed of a small stream up in Lennox Forest, and this one is a little bit out the way. The other slides are mostly taken from common public footpaths that anyone can access, but this one you have to sort of get off the beaten track a little bit. But there's the mudstone down in the bottom of the ditch down there. You see, it's quite a hard rock, smooth, laminated, and thinly bedded in the base of the thing there. On the sides of the ditch, though, it's much more heavily weathered, and there's a little bit of superficial deposits over the top. And this was dry weather in May, so there wasn't any water going over it. Mudstone, because it's a weaker rock than the sandstones and the dolerites, tends not to be exposed so much unless it's covered by a harder layer of sandstone or the lavas or something of that sort, which you do get in things like the Spout of Balagan and various exposures along the Campsies and one or two other places, but they're a little bit further away from us here, so I've not gone that far in this presentation. But there's an actual mudstone in the flesh for those who wish to see it. Talking of colliery spoil tips inevitably leads on to the other evidence of old mine workings that are around the place, and there's a lot of that. The area around Lennoxton, between Lennoxton and Torrance, it was one of the earliest areas where there were extensive coal workings in Scotland, perhaps because being hilly there were more exposures and people knew there was coal there at an earlier stage and started digging it out. And there's lots of old telltale signs of old mine workings in this area. The first and most obvious in the shot there is an old mine shaft. You can see the area that's fenced off there with a tree growing in on it. There's numerous old mine shafts in these areas. They've not been capped or treated in any way to be made safe. So in order to stop people or livestock falling down them, they've been generally fenced off, and of course that then leads to the bushes and trees and shrubs growing there because it's free from grazing animals. There's lots of these all around Lennox Forest, on or beside a lot of the paths up there. They're all over the hillside around here in various places. And there's various other signs of mine workings in there, sort of little platforms and broken ground around there. All this was worked out by mid-Victorian times, and the strata have subsided above the old mine workings and settled down, so it all looks quite disturbed. Other signs of old mine workings are ferruginous seepages and ochreous deposits in streams and ditches. And this is down beside the railway path, down beside the glaciers at the foot of the hill. And the drainage from the old mine workings is very rich in iron, and it stays in solution as long as it's underground because there's very little oxygen in the water there. But as soon as it comes out into the atmosphere, it oxidizes very rapidly and precipitates as ochre, this sort of hydrous iron oxide in there, which coats the ditches and gives you this attractive in one way and horrible in other ochreous deposit, which blankets things and kills off all the life in there. This is beside the railway path back in May. And if we go just a little bit further up to the bridge over the glacier, just on the edge of Lennoxton there by the Highland Spring bottling plant, you can see these ochreous colours of the bed of the glacier all the way along here. That is seepages of this ferruginous water that's coming out through the old mine workings into the bed of the river. You may also note that yes, that is ice. On the other side of the river. It was a bright May morning, but it had been quite a cold night, and there was still ice on the thing there. So that's a look at some of the evidence we've got for what lies beneath the surface of the ground, and some of the geology that's in there. We can't see much of the bedrock, so what can we see if we look at things from the surface? And this slide, of course, takes us back to the Waterside Bing and the view north across to the Campsies. And it's a useful way to illustrate the main features of the landscape, because in the foreground here you've got this gently undulating farmland and then Kirkintilloch itself. That is all underlain by glacial till, by deposits laid down by the glaciers, ground up soil and rock in there. Then you've got the actual valley of the Kelvin running through across the middle of the slide up there, and all the way up and down to Kilsyth and beyond. There's a major topographic feature, the Kelvin Valley. So starting with the glacial deposits, and we'll just orientate ourselves. That's Waterside Bing up there. But we've come over here, we're actually just at the edge of Calfmuir Road, south of the railway, south of Woodley Village, and looking across to there. And you've got this kind of undulating landscape with mounds, sort of east-west direction, where the glaciers have smeared out the ground up soil and rock, and gives you this very hard-looking material called boulder clay, and it contains everything from boulders to clay. You can see gravel, stony particles in there, the fine-grained reddish brown matrix in there, which is very hard because it's been compressed by the glaciers. Quite rich in agriculturally in minerals, but the water sheds off into the hollows in between these mounds. And if they're not drained, you get boggy hollows developing, you get peat developing, and sometimes you get lochs like the Gadloch developing. So this is typical of the landscape all around Kirkintilloch and Glasgow, west central Scotland. And most of it is underlain by this undulating glacial till landscape with boggy hollows with recent alluvium and peat and things like that in between. You don't often see the boulder clay except in excavations for foundations or transport works of one sort or another. So here's an example from the centre of Glasgow just in March of this year, just before lockdown was announced, really. And it's this dark grey material in the upper part of the exposure there. You can see this boulder stones all the way through it, dark grey matrix. This was very much derived from the mudstone, which is dark grey or black in colour, and so the ground up matrix would be dark grey and black. The boulders tend to be the harder bits of rock, dolerite, basalt, sandstone and limestone and so forth. All the finer grained stuff gets ground up into the matrix. You can also note here that we've actually got the bedrock, which is mostly a mudstone, a black mudstone with some sandstone bands peeking out at the bottom. So it illustrates how the boulder clay overlies the bedrock and kind of protects it. So you can't see the bedrock because the boulder clay overlies it. At the very top, the boulder clay is weathered in the top couple of metres. It's a paler colour, and then you've got the topsoil and the vegetation growing on top of that. So that's the boulder clay. We now come to the great sword cut of the Kelvin Valley that runs right across the district just to the south of the Campsies, all the way through to Banknock and beyond. It's a major geological and topographic feature, runs across central Scotland. Here I've come a little bit out. This is a picture taken from Bar Hill on a lovely November afternoon, slightly misty, back in 2013. And it shows this great trough of the Kelvin Valley, and actually looking up the Glacial water there as well. This valley was dug out by the glaciers during the ice ages and over deepened, and it's been infilled with a great mix of sediments, sands, gravels, and various other materials in there. But near the surface, it's mostly glacial meltwater deposits of sand and gravel that form the topography. And there was little alluvial deposits in the centre where the actual watercourse was meandering about. Now this sand and gravel has been very heavily used and extracted for construction, for concrete and things of that sort, and there's very little of it left because it's mostly been worked out right down to the water table, which is why the valley is so flat. The Kelvin itself, of course, was drained and put into a straight ditch from there, which you can see running across the middle of the valley floor down there to improve it for agriculture. Unfortunately, the effect of all the coal mining, this is sort of the coal working sort of start around the Dark Shore area, run out through Twecker and out to Kilsyth, and there's loads and loads of seams of coal and ironstone and other materials there. And the extraction of all of these has resulted in the ground settling in subsidence, which has led to flooding at the surface in wet areas like there, because the water table is now much closer to the surface than it was before. So we have the old law of unintended consequences, which we frequently come across in life. So moving now to the Kelvin Valley in our patch, this is the river itself, just immediately at the north end of Kirkintilloch. You go across the Kilsyth Road and up along the path for about 100 metres towards Milton of Campsie, you come to this footbridge over the Kelvin, and we've got the Kelvin itself coming in on the right there, and the Glacial water on the left. And you may observe that there's a lot more water in the Glacial water than there is in the Kelvin. The Glacial coming down off the Campsies and the Finn Glen and Campsie Glen, full of lots of water running off there, whereas the Kelvin is coming through this very flat, subdued landscape, and it's just sort of ambling along gently. So although it's the smaller river, it gives its name to the whole system because the valley, the Kelvin Valley, is such a dominant feature topographically through the area. A little bit further down, we come to Hayston Golf Club here, just over the river, and we're looking across the flat valley from the riverbank to Kirkintilloch. You've got the old Kirk Museum on the left there, the steeple there, and St David's away on the right in between. And at the far side of the flat valley, you can see there's a flood bund there. That was built in the 1990s after a severe flooding during a very wet winter, which affected a lot of new houses that had been built down below the Glasgow Road down there. And so we learnt the hard way that if you build in a floodplain, you're going to get flooded, so you need to put in some protection. And with climate change and more extreme weather becoming more common, this is becoming a bigger risk. It's ever more important that we don't build on flat, low-lying floodplain land if all, really, because you're just asking for trouble, and it's going to cause better to sort of stick up on higher ground where it can be protected than on the low ground there. So to finish with, I've just come up out the valley a little bit to the canal, the Forth and Clyde Canal, looking at Hillhead Bridge here with the Campsies behind on again a glorious day. We had lots of these really glorious days in April this year, which helped us lighten a little bit. And of course, the canal uses the Kelvin Valley because it's the easiest way to get from the east to the coast to the west, from the Forth to the Clyde, through this long, low valley that runs through the middle. And by the time you get to Kirkintilloch, of course, the canal's come up onto the higher ground there, and it moves round Glasgow, and that way just to keep a level. And of course, the canal engineers weren't the first ones to use the high ground around here. The Romans used Bar Hill and Croy Hill, and then the high ground along Kirkintilloch and Peel Park for the Antonine Wall, and there's traces of that, of course, all the way along here. So all through history, really, geology has influenced the human behaviour, human activity. It explains why we're here and the history of the place. So with that, I'll leave you with just one final slide, which is a few references for further information. A very good pamphlet on the mines and minerals of Campsie that was published by Kelvin District Libraries back in the 1980s, and some of the geological solid and drift edition maps that I consulted, and the Geology guide. So that concludes my presentation. I hope you've enjoyed it. Thank you very much for watching and listening, and look forward to being able to give this in person at some point in the not too distant future. Thank you very much. Goodbye.